All right, Logic 1, it's nice to see this textbook. I was going to say it's nice to see you, but I'm looking at this textbook. I hope you're well. Hope lessons 91 and 92 made sense. If not, we're going to have a Zoom check-in tomorrow just to make sure that you get everything that we've done so far and that you just feel comfortable with everything. And also, it's fun to see everyone. So let's go ahead and hop into lesson 93, one of my faves. I wish we could be working together on this one because this is just a really good lesson to see up on the board. So we'll do our best given what we have. Make sure that you've done your facts practice already and your warm up, that problem solving as well. And then let's go ahead and hop into two-step equations and inequalities. So we know that equations are a lot like a balanced or just like a scale. Really, the big idea with an equation is that we want everything on one side to equal everything on the other side, because literally equals means the same as. So even though we have 2x plus 5 equals 35, or two different quantities, they represent the same exact number. And it's our job to figure out what value does x have to make this numerical statement and this numerical statement equal to one another. So if you look at the scale, you'll notice that we have two x's and a 5, and we have a 35. So we know that we want to combine our like terms. And if you look at this equation, 5 and 35 are like terms and need to belong together. I kind of think about this in terms of making sure that you are isolating the term that has the variable by completing the opposite of the operation being done. So right now we have 2x plus 5. So we're going to go ahead and subtract 5 from this side and from this side. Well, I hopped on over to my whiteboard because I think this just looks so good when we can do it and we can see it. So when I do my two-step equations or multiple step equations, I usually draw a line down my equal sign to differentiate the two sides. And then I say, okay, in order to isolate this guy right here, I need to get rid of this plus 5. And I'm going to do that by subtracting it from both sides. Whatever you do to one side, you got to do to the other because you're trying to keep it level. 2x comes down because we have not touched it. We know that 5, positive 5 minus 5 is 0, so those cancel out. Bringing my equal sign down on that line, 35 minus 5 is 30. So now I have 2x's is equal to 30. So I'm going to do my opposite operation, which is dividing by 2, because I'm trying to isolate x right here. Well, 2 divided by 2 frees up x to be all by himself. So now we have, because really 2 divided by 2 is 1x. And we don't have to write that 1, but so that you understand that x is by itself. So 15 or 30 divided by 2 is 15. So let's go back over to our math book and let's go ahead and flip the page. And all right, so I went ahead and widened our textbook, and we noticed that same thing, we have x is equal to 15. But we're not done. I want you guys to check it. So let's go ahead back to the whiteboard and say, oh, forget about that, that was the last lesson. So let's go ahead and check it. If x is 15, then we're gonna go ahead and put it back up into our original equation. So that our equation is 2 times 15 plus 5. Does it equal 35? And if that value is 15, then we should have 35 on this side and 35 on this side. Well, 2 times 15 is 30. We know 30 plus 5 is 35. So yes, 35 does equal 35, which means this is the correct solution for that problem. Let's do the next one. We have 4/10 x plus 1 2/10 is equal to 6. So if we go ahead and write that out here, we have 4/10 x plus, what was it, 1 2/10 is equal to 6. And we're going to draw our line, a very squiggly line. Guys, I'm trying. This web whiteboard thing is not the easiest for me. All right, so let's go ahead. Again, our end goal is to get that x all by itself, which means we got to get rid of this 1 2/10. So we're going to do that by, sorry about that, subtracting from both sides. There we go. So now we haven't done anything with 4/10 x, so we're going to bring it down. I can do my decimal. 0.4x is equal to, well, now let's just go ahead and do this math. What is 6 minus 1 and 2/10. Well, we can't take 2 away from 0, so we're going to make that a 10, and we're going to borrow that. And now we have 10 minus 2 is 8, 5 minus 1 is 6. Well, we're not done yet because these are being multiplied. Divide both sides by 4. Both sides are 4/10, gee whiz. X is equal to, hey guys, notice I made a giant mistake right here. What is 5 minus 1? I wish you guys were in class to be like, Mrs. Bunker, what is 5 minus 1? And I would tell you 5 minus 1 is actually 4.8. There we go. Sorry about that. Anyway, when you divide 4 and 8/10 divided by 4/10, you get 12. And there is your answer. Let's go ahead and do this equation right now. So Saxon loves to do equations with fractions because sometimes fractions can look scary, but really it's the same process over and over and over again. So I'm going to open up that whiteboard. Let's go ahead and do it. So hold on. So here is the problem from example 2. Right here, I put it on our whiteboard, and we're going to apply the exact same steps, even with fractions. So we're trying to isolate negative 2/3 x. We have a negative 1/2, so we're going to add 1/2 to both sides. And we're going to come up with, we haven't done anything with negative 2/3, so negative, that's a 3. 2/3 x is equal to, so now we just got to go ahead and find our common denominator. So we need to add, 6 is our common denominator, so we multiplied by 3. So our numerator is going to be 3. We multiplied by 2, so we're going to multiply our numerator by 2. And now we're going to add, since we have common denominators, and we have 5, 6. So now in order to isolate x right here, we're going to multiply by the reciprocal. Well, the reciprocal of negative 2/3 is going to be 3/2. Don't forget to bring that negative sign over. So our negative reciprocal, when we multiply this, we get 1. So x is equal to, but whatever you do to one side, you got to do to the other. So we're going to multiply this by 3, or negative 3/2. Let's go ahead and multiply. Can we reduce within our fraction? Yes, 3 can go into 6 twice. Cross off that 3. And now 5 times 1 is 5. 2 times negative 2 is negative 4. And there's our solution. Let's check it with Mr. Saxon. Oh, bingo, right there. X is equal to negative 4. Now let's come over here to example 3, and we have negative 15 is equal to 3x plus 6. Let's go ahead and write it. Negative 15 is equal to 3x plus 6. Make sure, guys, that you're doing this on paper. You have lots of room to work. So nothing has changed. The end goal is to get x isolated. So we're going to subtract 6 from both sides because 6 is the term we're whittling away. So 6 minus 6 is 0. 3x comes down. And now we have negative 15 minus 6, which is negative 21. We're going to divide both sides by 3 because we are trying to get x to have a coefficient of 1. So x equals negative 7. And there's your solution. Let's check it with Mr. Saxon. And there we go. So our final example, at least I think our final example, final example is solving an inequality and then graphing its solution. So we're going to treat this just like we would a normal equation, isolating x and then dividing by 2. And then we're going to graph it on a number line. So let's go ahead into the whiteboard. 2x minus 5 minus 5 is, what was it? Greater than or equal to 1. So just treat it like you would an equal sign. We're going to add 5 to both sides because we're isolating 2x. And now our new inequality is 2x is greater than or equal to 6. We're not done yet because we got to divide by 2. We're whittling away that equation so that x is greater than or equal to 3. So now on a number line, if I have 0 right here, 2, 3, 4, 5, 6, 7. So 3 is going to be right here. So what this is telling us is that the value of x, that solution, could be any number greater than or equal to 3. So we're going to go ahead and we're going to color in very poorly all the number line to the right of 0. Since we have that or equal to symbol, We could also say that 3 is a solution. Sorry again for how terrible that looks. So if 3 is a solution, we're going to fill it in, and then we're going to say any number greater than 3 or 3 could fill as a solution. So let's go ahead and let's show you that. Let's say we picked 5. If we plugged 5 into this equation or inequality, so it'd be 2 times 5 minus 5, is it greater than or equal to 1? Well, 2 times 5 is 10, minus 5 is 5. Is 5 greater than or equal to 1? Yes, it totally is. Since that is a true statement, we know that this number line and that this value is going to be true. Let's go back to Saxon. And I think that's the last problem. Yep, there we go. All right, guys, get out your lesson practice. I would love to see your solutions when we check in on Thursday. Tomorrow we do have that Zoom check-in meeting, so please come prepared to show me this because I would love to see your equations and of course to see you guys, but make sure you give yourself space. I want to see those inequalities graphed on a number line because this is a huge concept that you guys are going to use for a very long time. So this was a long lesson. I'm super sorry. You guys are awesome and can't wait to check in tomorrow. Okay, bye.